Our next talk will be given by Stephen Worth, EMC Corporation, on EMC Metalnx, iRODS Admin and Metadata Management Interface.
Thank you. So let me let everybody get back in. Can you hear me okay into the back of the room? Okay, good. Thank you, Reagan. And of course, I think everything can be seen. I'm going to apologize in advance for two things. The first of these is that I do intend to do a bit of a live demonstration, and for some reason I could not get PowerPoint and my Lenovo laptop to agree and not extend the display versus duplicate, so I'll have a little bit of flash and bang a little bit later as I switch gears. The second is it was pointed out to me by some friends of mine that I have a graphic up on the screen that probably deserves a bit of explanation. In good context, I'm a faithful company employee, and I've used some of our standard graphics which depicts how the cloud and virtualization works in the infrastructure. And while I admit that EMC is known for testing its systems very hard and heavily, we don't necessarily test them so bad that they catch fire and burn, as this graphic seems to indicate. It's been pointed out to me that looks like smoke floating down the hallway of the servers. But and if you're offended by that, I do apologize. Feel free to beat me up in the hallway later. I want to start off, though, before going to the demonstration, and talk a little bit about what motivated us to start looking more into the use of metadata. And that's really what this is about from our point of view. I won't go into the history, but I have some personal experience dating back about 10 to 15 years of trying to use advanced metadata for different ideas way before they were of any value in the computing industry. I've learned a few lessons about what not to do, if you will. And we got to looking at what the current trends in computer technology are doing in the environment. And as we look kind of at a meta level, and I'm talking about more than we would typically do in our sales pitches and so forth, we see some of the trends indicating that the use of advanced metadata is really going to accelerate in the not too distant future. You know, when you take a look at the fact that there really is a data deluge, or if you will, tidal wave about to crash on us, EMC sponsored some studies back in 2012 and 2014 looking at the amount of data that was going to be evolving in the world, and we quit doing this because it got to be too scary to look at to some extent. These studies have all shown that when we start approaching 5 years from now, 2020, we're going to move from having about 4 to 5 exabytes of actual digitized data we're manipulating in the world to close to 50. So, 5 years, 10x from where we are today. It's not quite hyper-exponential, but it's big and it's intimidating if you think about it at one level. The other one of these trends is the fact that we all clearly see that there's kind of this race to zero, if you will, in the cost of computing. And particularly when you look at it from a CapEx point of view, where we're looking at the cost of acquisition. But when you take into account the growth of the data that's coming, that race to zero will in time change to where it's not just looking at what the cost of getting the equipment is going to be. The cost of operating it is going to start predominating. In fact, we're already seeing this now with some of the folks that we interact with. It's a little hard to see here, but it's a little graphic I built as part of this preparation, taking a look at the cost of actually keeping 100,000 genomes over 5 years. And depending upon what kind of cost you're paying for, whether it's along the lines of 5 cents a gigabyte per month as you will for a higher-end storage capability, or looking down here into the middle around a penny a gigabyte, which is what you get with, if you will, the best of cloud, cold, archival storages, and even, if you will, 4x below that, you're looking at spending over 5 years somewhere between $2 and $35 million just to hold the information. That's not processing it. That's not moving it. That's not making copies to do processing. That's just keeping the bits on something, be it tape, disk, or whatever. So we believe that this is going to have some bearing as it goes along. And the third one of these trends is it's painfully clear if you listen to folks who work in large data sets that the data itself is becoming intellectual property. I mean, we've kind of known it. You think about search results in Google or how Amazon tries to present things for you to buy. But, we know that people use the insights out of this data for value, but the data set itself is going to become the thing that many companies are actually going to make their money off of looking into the future. I mean, think about it. Researchers have done this for years, right? The data that's in your research is the guts of that research plus the insights you derive out of it. So it's a pretty common practice. when you put all this together and then you start looking at the cost of moving the data around and how that's going to also add into this OpEx cost, there are many of us who think that people are going to become more reticent to just putting data up and moving it around all the time because it will become too expensive. And they'll start looking for proxies, if you, excuse me, they'll start looking for proxies, if you will, for how to work and understand what's in their large data sets without actually having to tear them open all the time and look through them and analyze them and so forth. And this is where advanced metadata, from our point of view, becomes fairly interesting. So we decided we needed to look more into this, and as we started studying, we of course ran across iRODS about 1.5 years ago and discovered, from our point of view, it was probably the most and best advanced tool out there right now for working with advanced metadata that is independent of the actual data itself. And so we started digging in to learn more about it. As we learned, we became so convinced that metadata itself is important that we've kind of changed our whole focus looking at this from a science project point of view as to understanding how the metadata can possibly be leveraged as time goes by. I think everybody in this room knows this, so I'm kind of singing to the choir here, but you know, we realize that it can be leveraged to help manage and understand what's in your storage assets. We know it can be used for helping with indexing and searching and things of this nature. There's some groups I know here in the room that are already working in this area. Obviously, with things like the rules engines that's available in iRODS, you can work on doing automated data movements and extractions and so forth. But one of the aspects that kind of caught our attention is that metadata itself, besides holding, you know, the structural and the time and other related data, over time can start holding contextual information. And when that occurs, it can become a very effective proxy for understanding what's going to be in these data sets, and fortunately takes a lot less room. If you just look at what iRODS does today, if you think about adding 1,000 metadata tags with the full, you know, if you will, character set contingent for each AVU set, you can describe 1,000 pieces of contextual information and take less than 12 megabytes of storage to describe it. That's easily movable, if you will, within networks shared between friends and, you know, enemies or whatever you want to talk about, and a lot easier to deal with than moving 3, 4, and 5 gigabyte data sets. So it's very appealing. Not to mention, metadata itself can be used very easily to help separate, if you will, private information, PHI, PMI, whatever acronym you like to call it by, but if you will, private information from public information as a means of moving it around. I have the honor of actually sitting on a couple of advisory boards for different computer science departments in the Southeast. And there's often a conversation we get into with faculty about where computer science is moving to and where its trends are moving to. For a couple of years now, I've been preaching to them the mantra that when you look at the Internet of Things and what it's doing to us, not only is it increasing this vast quantity of data I talked about, but it's also going to change our behavior about how we keep this data. And by that, I'm talking about the fact that, one, it gets to be so big, you cannot keep all of it yourself. I'll use my own self as a personal example. I'm a photographic freak. I've got about 2 terabytes of photographic data of my own personal stuff. And to be honest with you, I don't even want to get into describing the hodgepodge of spreadsheets I have to kind of keep track of what my photos are over more than 10 years. We'll leave it at that. But I believe that this need to use advanced metadata is going to lead computer science departments to have to create the next skill set, if you will. And that skill set is going to probably be called something along the lines of an information scientist or an information science area. You see it periodically, but not with the kind of rigid definition that you do around what will come about the idea of building hierarchical topologies, ontologies, and the infrastructure to make those work. People who are from the library science area, and I know some of you in the room are very familiar with this because this is what you studied and learned years ago, but it's really going to become more and more digitized. And if you have any doubt that I might be right, I'd like to show you a picture from a library that I'm also an advisory board member on over here at NC State. Oh, sorry, I need to click the forward. You go into the Hunt Library just 25 miles down the road and look around. And I challenge you in under 30 seconds to find a rack of books. There are not many. The books are all inside of a giant automatic storage and retrieval system in the middle of the building. You can't even get to it as a human being. You have to walk up to a kiosk or an online web application, and guess how you search for material? Hashtags. And if you have any doubt about the fact that the college student of the day doesn't know how to use a hashtag, you should look at them use Twitter, Facebook, Instagram, or anything else. They know how to search this information so fast that, at least for me and my age group, makes my head spin. So I have no doubt about the fact that this will be readily adopted as the years go by. When we started looking into this, though, we needed a way to understand how people are going to use metadata. We couldn't easily get to the kind of information we wanted, so we decided to start the project that I'm talking about today, which was looking at how to find a way to make things easier for people to make use of metadata and to begin expanding its concept and its use. And as we looked at what areas we had to focus on, because there are many different verticals, we decided to focus in the area of genomics research, not because it's any better or different than anything else, but from what we all knew in my group coming forward, it had all the aspects of using all the elements of computing. It has large data sets behind it, and as near as I can tell, probably one of the better uses of metadata today, and particular interesting curation needs. Genomics research is probably the area where the idea of real, legitimate, multi-generational archiving is going to be expanded upon outside of groups that have the charter and responsibility for holding historical archives. Say, for example, a national archive or long-range weather data or things of this nature. So this is kind of the new area that we saw coming. As we talked to people who actually do this work, we learned a couple of interesting things. All of you may already know it, but we didn't. And that is that there are really two kinds of user groups that work with the genomic data. One of these are obviously the traditional system administrators who stand up machines and make sure they're backed up and all the network connections work and so forth. But the other was kind of a combination of researchers who are doing work that uses the data to leverage it and curation. And curation was an interesting concept to us, not because people didn't think of having data managers, but the curator seems to have this interesting role between taking care of making sure the data is in the right place in the right ways, but also in making sure that it has the right kind of annotations around it, be it strict structural annotations, phenotype annotations, contextual annotations. It kind of varies. And what was even more odd to us from working a lot with traditional IT people is that a single individual may serve one or more of all these roles. Well, since we were looking at iRODS and we talked to these very same folks, we learned another little interesting thing, and I don't say this to be derogatory to the creators of this wonderful product, but unless you just really like command line interfaces, it's not trivial to use. You have to learn a bunch of stuff. And as we talked to people that we had interfaced with who were still looking at it and maybe not totally bought in, we came up with the idea that if we could make iRODS easier for people to use, particularly the administrators who have to stand them up and keep them running, and then the researchers who need to interface with it, we could possibly learn more about how people are using the data. So this is roughly where we're at. The tool that we have ended up trying to put together, which we called Metalnx, is essentially designed to help in both of these areas. And so I'm going to try to switch now to showing you some of its capabilities. But I want to make sure you're aware of the environment as you see me have to switch things around. The laptop I have over here has a 3 VM setup environment. We have a single iCat server that's on one virtual machine, a resource server that is set up on a second, and then a third machine is where we're actually going to run the application that we've been working on. And if you'll pardon me, now is where all the flashing is going to occur. I'm going to try and bring the demonstration up without making too many changes for you here. Hopefully this worked. Excellent. So please forgive me for a moment. I'm going to have to log back in on my own utility. It's been down too long. But The application itself is designed essentially as a JavaScript application that runs under a virtualization framework like Tomcat, which is what we're using, but it can certainly go to others. The structure itself is designed to work directly with iRODS, but we've also at this point completed enough work to be able to interface it through LDAP if there's interest in doing so. But we recognize because of these two user groups, we are designing this application for the moment in essentially two modes. There's an administrative version mode, if you will, and a user mode. If you'll notice there's a little switch up here in the upper right that as an iRODS administrator I could switch from to see one view versus the other. A user would not typically see this administrative view. As we talked to people, one of the things they pointed out, and Jason and the group have been working on with the Rev 4.1, is that being able to correct and find out what's going on in a grid can be a bit difficult. When we started this, obviously 4.1 was way under early development, so we've been working predominantly with Rev 4.0 and 4.03. But what we started off was realizing an administrator wants to understand what the state of the grid is. So when you log into the screen, the first thing that we try to do is to go out and query, if you will, in the background, all the resources, but not just from the iRODS side of the resource. We're going underneath and talking to the Unix side of the resource or the Windows side of the resource to understand, are the systems really up and operational? I'll show you a simple way of understanding this, and pardon me, I've got to switch out of full screen mode for a moment. Well, come on, machine. There we go. And what I'm going to do is to go to one of the resource servers real quick here and actually execute a command that will shut iRODS off, wait 20 seconds, and shut it back or turn it back on. And while that's going on and it's actually shutting the environment down, what I can do is to essentially refresh this dashboard query, and we're going to be able to tell that the server in the back is no longer in a sane state. That could be either from a network dropout, iRODS service being down, some other kind of connectivity issue. We've tried to arrange this so that we can go to drill downs on the individual server pages and even scan through to see the contents of the iRODS log. As you can see somewhat here at the bottom, I can't quite read it from where I'm standing. It's too small, but there should be a line in here that talks about catching us. There it is, catching signal 2, which is a formal exit command. And that would tell me, of course, as a user who's used this for a while, that the server itself is down and I need to go start it back up, which with the new control plane you can do easily with that command set. And once the server is back up and operational, the dashboard, will come back and tell you that it's all back alive and well. So we've tried to provide information about the status of the servers, the storage that's available, and so forth at the top. We also understood from talking to the administrators in this that there are a couple of areas where some help was needed. One of these is in the aspect of creating users, handling groups, and setting up collections. And towards this end, while I won't get into demonstrating all the capabilities, I want to highlight a couple of areas. In the aspect of working with users, I'm going to just edit one rather than creating one from scratch. Pardon me a second while I scroll this to the right place. But you provide, of course, obviously the information you need to create a user, and such as you're seeing over here. And, of course, you pick the role for the user. But one of the things we chose to add was this idea of a user profile where, through the other menu screen I'll go to in a moment, you can essentially create a named profile that will say what groups are attached to an individual created using this profile. When you create the user, you pick the profile, you click Save. It updates all the information, and when that user is created, the groups that they should be involved in are automatically added to their profile, and it actually saves a number of manual iAdmin steps that you would have to go through to do this process individually. One of the other things that we've also taken some steps to do, though it's impossible for me to demo in this environment, is to actually tie the creation of users back to something like an LDAP. So if a user is created in an LDAP environment, you can import it either automatically or in bulk with a couple of scripts we've written from the outside environment. In the case of groups, obviously you want to be able to work with an individual group, and inside of a, hang on machine, there we go. Inside of a group, you can, of course, see the users that are already assigned. You could add new users to it if you wanted to by just clicking and picking and adding them on, saving the results. Oh, sorry, got to hit the apply and hit the save. And likewise, within an individual group, we can also scroll down and actually change who has permissions relative to the group membership for different collections and so forth that they may or may not have permissions to. We can change the permission value from none to read or write or ownership or whichever it needs to be. So we've tried to make that a bit easier. And then finally, in the area of collections itself, which probably becomes a bit more interesting, we've attempted to try and make it so that you can work inside of the collections in a natural manner. You may notice that this interface is designed with a particular purpose in mind, and that was to basically be web deployable, scale-out type of architecture, and it is designed so that this interface is consistent between a Windows, a Mac, a tablet, or whatever interface you'd like to use with it. So we've done our best to try and keep that consistent. At this point, rather than beating you up over administration stuff, I want to look a little bit about actually using the information. And, of course, I take that back. One last thing is we also realize that administrators want to know a little bit about the resources and where they live, so we've tried to create some tools to make it easy to visualize where the storage resources are within the grid and see the information about them, or likewise to be able to tear apart the resources themselves on a server-by-server basis, which is what people have told us they typically end up having to do, mostly with manual command operations. If you will, though, let me switch to the user style of mode. And here, of course, we have the ability to go to our home collection, to the public collection, even to the trash can if we want to go and deal with files that are there and recover them. Within a collection area, though, and I'm just going to do a couple of examples here fairly quickly, we can do, for example, let me see, I think I should have a simple directory I've used before that we can create. With the directory created, we can then actually come and upload information files from other places. And please pardon me, rather than using large genome files, I'm going to use a collection of personal photographs because they're just easier to work with in real time. But I'll come here and select 2 or 3 fairly quickly, and we'll add them to the list. We can certainly add calculating of checksums like you would with an IPUT command. We can even, if you desire to do replication of the files as they're being inputted, or excuse me, I get it. They come into the system and you can, of course, see them. You can then, if you would like, click on any one of them and select actions that you'd like to take against them. But probably what's of more interest right at this moment is just understanding that you can get to the data that's available about the files that are in the collection. We are breaking out the different replicas so you can see them by number and choose to keep or delete or whatever you need to do with them. And we took some time, I think all of you in the training class got to do this yesterday, but it was we did something similar. We actually go and rip out, if you will, at upload time, all the photo metadata. We're able to do this now with BAM and VCF files in general context. We're still trying to debate whether or not there's anything practical to do with things like FASTQ files, but certainly the data that's in there we can extract and add in automatically as AVU tags in the system. You can, of course, if you wanted to delete a tag at this point, we're still trying to decide if we should make that optional or not. But you can add tags if you wanted to. For example, I might not like the orientation 256 flag that I know is already in here and change it to something that's a little more human readable, like so. And if I do so, you'll see down here in orientation we now have 2 flags, or 2 attributes, the one I added and the one that was automatically extracted. So this information is there. You can also look at the permissions on the file or go back if you want to. And then we realize that this in itself just kind of does basic file manipulations, move, copies, and so forth. But what's really valuable is being able to go through and find information that you want out of the files. And to get to, if you will, this demonstration today, we have focused on what we could do with metadata. And what we've worked a good deal on the last 5 weeks has been the idea of trying to actually do direct metadata searches. Essentially, if you will, put a graphical front end around IMeta type operations. And what we can do with what we have now is basically look for a collection of metadata tags that you can add on in pieces if you want to. For example, we could take a look to see, look for files that has the orientation where the word landscape that I just put in. And I apologize, I cannot talk and type at the same time. But we can, make a tag search like this and find the files that are there. If you want to look for other types of tags, for example, maybe I want to see every file that has orientation in it. To do that, the easiest way to do it is to say orientation does not contain landscape. Oh, sorry. Thank you. I'm glad one of you is paying more attention than I am. Whoops, I'm sorry. In my case, it's going to be easier to just pick a different word. I'll use foo. But when you do this, it actually goes through and runs the necessary SQL query, comes back with the pattern matches, and we're actually showing you the catch of the pattern matches so you can have some idea in sorted order as to which ones will be of more value. You can then, of course, come down and click into a file, take a look at the information about it. Again, you can look through the metadata or add or delete from it as you wish. You can come back to your search results if you want to add or delete search tags and change things as you're moving along. We've also figured that some folks would really like to be able to just take these kind of search results and bring them into some kind of a comma-separated capability that they could bring into some kind of a tool like an Excel or other sort capabilities. So we tried to make sure we could do that. And then last but not least, an area that we have been working on as well is the idea of being able to apply templates. One of the things that many folks had talked to us about is trying to add, if you will, not just contextual, but sample and other types of data that they need to their work that need to be regularized, if you will. And this is a first attempt to put some of that together so that we can get input from others. But in the idea of creating a template, and I'm using photographic type stuff here again because it's easier to see, but we can come through and generate a template that can either be made public or private. Through a selection here, private means, of course, you can only run it yourself. If it's public, it's viewable by everybody and usable by everybody. But you can come in and define, if you will, attribute tags that you would like to have added to the file and actually set basic values to them. We can, of course, come back and change them if you wanted to. For example, could add this, and instead of that saying auto, it might say none. I make the change in the file, and of course the metadata template is now edited. But then to use it, I would say come back to my collection. Let me go to the few photographs we just put in place. I would pick a apply template function against it, pick the template, and I hate to say it, I think I used the bottom one. I can't even remember right now. Pick the template that we thought we picked up, and as you'll notice, it comes up with a page that allows you to view the template values, if you will, that have been set there. You can change any of them that you like. I could, for example, come in here now and change flash from none to never. Except I don't believe I spelled that correctly. We click apply, and the template is applied against all three of the files that we selected. We can go into actually scan through the metadata. And you'll see as we go through, the tag for flash has been added. The value has been set to never. Some of the other tags that I believe define physical location and the photographer and so forth have been added as well. So this was a nice way to kind of put it all in place. And with that done, I wanted to stop and actually have some time to take a few minutes for questions. But before I do, if you will, let me quickly slip back to the other presentation for a moment, because there are a few things, a couple of points I want to make about it before, well, there we go, before you walk away. So we're putting this tool together. Its goal is to try and help make it easier for people to work with metadata, if you will, inside of iRODS. We believe it has a few features to it that are finally, fairly valuable. The simple, easy interface part. We hope and pray that we're doing things that make it more useful, if you will, for folks who are not intuitive about using Unix command sets and so forth in a way they can kind of figure it out for themselves. And we're definitely trying to work in the area of making metadata easier to work with, the searching and type tools. And we've done some design work to make sure this is scalable. But oddly enough, this is not really all of our focus, because this is, at this point, still a bit of a science project for us. This work, along with some resource drivers that we've been working on that Patrick Combs will talk about tomorrow afternoon, are pieces that EMC are building trying to understand better how users and customers and so forth want to work with metadata. We're actually now in the mode where we have some of this out. We're doing some beta testing and are actually looking for more beta testers. And I certainly would like to offer any of you the opportunity, if you want to get up with myself or members of the development team. Enrique, Arthur, Melini, will you raise your hands real quick? Feel free to reach out to any of us during breaks while we're here, because we'd love to sit and let you look more at this or talk and take your input about it, because we're in the mode where we want to get feedback right now. I also want to leave you with the thought that while we have focused this on genomics just as we needed to concentrate on a vertical, we believe the methodologies, the ability to use microservices and rules to do automated extraction and so forth are extendable with this interface across any kind of data vertical that there may be. But certainly we would love to get your input and feedback on that. We have, if you'll pardon me, let me skip ahead a couple of slides real quick. We definitely have work that we want to do more on working with metadata itself, but there's some other areas of things that we already have on our roadmap to kind of to take a look at. And again, we'd love to hear any feedback you might have about any of these areas as well. So in the interest of not overrunning my time, I'm going to stop and see if there are a question or two that I should take before I stop. Yes, sir.
Is all the functionality in Metalnx based on iCommands only, or is there any deep diving into the source code?
At this point, it's kind of funny. It depends upon the area, because to get the scale out part, we've tried to use the things that are generally available in the user community. There are a few things we've had to jump and go all the way down on to keep the speed up we want. We're using a combination, if you will, mostly of jargon to do the basic or if you will, the iCommand operations. But for some of the things about getting service status, we've actually had to write our own daemons that run on the iCat and the, if you will, resource servers to report information back. And in some cases, we've actually had to go to using specific queries and direct-to-C operations, if you will, through the standard APIs to get to the core information we're after. So, does that answer your question? Okay.
I had a couple of questions. So one is, from your experience with working with genomics people, because we have some genomics people at UCL as well. Did you, I assume you've already tested this with them to some extent.
We're in the process of doing that now.
And do they prefer to use this sort of in real time, like they curate their data as they're going along, or is this sort of when they're finished and tidying up their data that they like to do this?
So it's actually going to depend upon the individual. As we were looking into trying to do what we could in time, because I won't pretend about this, to get user feedback, we've been trying to get pieces of this ready to both show at a BioIT World a month and a half ago and at this event. And so there's some things I know we need to do that we've not finished with. For example, bulk operations we had to put onto the back burner for right now. That's one of the areas we're going to pick up. But to answer your question more directly, what we have found very quickly amongst ourselves and the people that we're working with is that you typically tend to use the iCommand set to do, if you will, scripted-oriented operations. People who have that capability still prefer to use them. But then what we're finding is that anybody who is not doing something that's with their script pretty quickly gravitates to wanting to use this for most things because they don't have to remember the commands.
Okay.
So I think it's going to depend upon the individual user, to be quite honest.
So my one other question is, with your web-based GUI, how does it cope with the transferring of large files, like multi-gigabyte to terabytes?
Believe it or not, that's the reason we put the bulk operation problem to the back burner for right now, because the amount of file that you can transfer through a web UI is always a function of how much memory is available for that particular application in your operating system environment and browser and so forth, and it varies from browser to browser. One of the things we know we're going to be doing is trying to implement a capability to where we can deliver a payload, probably through iRODS directly itself, to do the large file bulk operations and report the status back to the individual without leveraging the browser.
So you found this works well up to like 50 megabytes?
No, right now we're finding, depending upon how much stuff you've got going on your machine, it's kind of, probably the best is Firefox right now. It tends to go up to somewhere between 3.5 and 4.5 gigabyte file before it barks at us. Google's a little bit less. Microsoft Explorer totally depends upon what the workload on the system is you're using. So, yes, sir.
Is the code for this available perhaps as open source, and can you tell us a bit about how you built it?
The code itself is built as a layer of information. Again, I'm saying we're using a lot of the stuff that's actually in the, if you will, the iRODS community, predominantly iRODS, its libraries and jargon. In terms of building our tool, we're leveraging, if you will, a JavaScript container. In our case, we picked Tomcat for right now. But the libraries that we're using into it include things like Hibernate for talking to the operating systems. We're using, pardon me, Enrique, I'm going to lose my mind here in a moment. Spring, thank you. We're using the Spring framework to actually do most of the interactions. I should know better. Spring is one of our products. That's bad. I'm sorry, everyone. And we've been picking up other tools, if you will, out of the user community. I think there's about 4 in total that we're using right now, and probably going to pick up a couple of more to finish building out this framework. But the application itself at this point is essentially self-contained. The pieces that we're picking up are linked in as shared objects when it's built, and so you know, we're not changing any of the other tools that we're picking up. We're just leveraging them as they are. Does that help? Sir?
Is the code open source at all?
Well, we're still debating that. Don't mind admitting it. You know, we're a for-profit company, of course, but this kind of application is not something that we would want to try and sell as a direct product. So I'm sure we're going to be putting it into open source. What we're trying to work out internally right now is how far do we go before we do it? In other words, when's it kind of done enough to put out? And when we do, whether or not we want to tie it to use with our products or not, I don't think we will, but that's all being debated internally. The big thing right now for us is that we need to get more participation with people to use this under live fire testing to tell us, you know, how much more we need to do, what does it need to be, what parts do need to be into the public domain so that we can work all that out. So the intent is to get there, but you know, I can't tell you for sure right now exactly what our final solution is going to be. Love to chat with you about what you think. And if y'all will pardon me, I need to stop or I'm going to take time from the next group. So come, you know, feel free to grab any of us and talk to us. Thank you.